Hello there everyone. We are going to look at another current shape, and this current shape is a loop now, and we want to find the magnetic field value and direction at the center of that loop. This is kind of like a loop, if you will, and let's look at it. This is a loop that has a current that is going this way, as you can see. All right, and we need to find exactly the value and the direction of the magnetic field created by the current that is going into the loop at the center. Okay, that's it. All right. Okay, so let's see if we have, for example, this is a current that is doing like this, and this current is making a loop, and the center of that loop is here, and the radius of this loop is R, and we need to find the magnetic field here. We don't know what the magnetic field value or direction. Okay, let's start with the direction. There's two ways to find the direction. Look, you see the current? Current is going this way. So one way to find the direction is you grab on the loop such that your four fingers point where the current. So my four fingers are here and they are pointing towards the current. Then the thumb will be the direction of the magnetic field at the center. So basically the direction of the magnetic field at the center is this way. Okay? There's another way. If you want, you can grab on the loop such that your thumb now points to the direction of the current. Your thumb. Then your four fingers are going to loop on the loop, and they're going to point to the magnetic field direction, which is at the center this way. So this could be the third right-hand rule if you want to. So there's two ways, whichever you feel comfortable with. Either you grab like this, then your thumb is where the direction of the magnetic field, or you grab on it so that the thumb points now to the direction of the current, then your four fingers will be directed towards the magnetic field direction. Okay, and so this is for the direction. Now for the value, the magnetic field here, we can use some calculus to derive it, but we're not going to do that. So it's going to be I or mu naught times R over 2R. So that's the value. Now we found the direction, we found the value. So mu naught, you know, permittivity 4 pi times 10 to minus 7. I is the current, so if that was the current. R is the radius, and 2 is just a number. If you remember, for a straight wire, if you want to find the magnetic field at a distance R, here the magnetic field is simply equal to mu naught I over 2 pi R. See the difference between the straight wire and the magnetic field for a loop? It's just the pi. The pi is in the straight wire and it doesn't appear in the denominator of the loop. Let me ask you a question now. What if you have n loops? Like instead of one loop here, you made n loops, like hundreds of them. So how does that affect the magnetic field at the center? Well, for n loops, the magnetic field at the center is going to be equal to mu naught I over 2R multiplied by n. So for each loop you actually add another magnetic field of the same value as the one before. Okay? So if you want to make a huge magnetic field at the center, you can put thousands of loops if you want. Of course, there are engineering design problems with this whole thing, and that's not our problem. It's the engineer's problem. Okay? Thank you very much.